Hello my dear friends, welcome to Edosastra and welcome to this course on MATLAB and SIMULINK. In this lecture, I have introduced both MATLAB and SIMULINK, but this course is particularly for MATLAB. So, basically this course is nothing but the foundation of SIMULINK. Hello, I am Sikandar Pandit and I have more than 10 years of experience in MATLAB and SIMULINK. I have contributed in design and development of GNC for missile systems, cruise missiles, UAV by using model based design approach provided by MATLAB and SIMULINK. I hope I can provide you the best learning experience of MATLAB and SIMULINK. So, this course is designed interactively in which you will run a piece of code by yourself and observe the output. Try to change that code, try to tweak that code by yourself. You will be able to analyze the code, understand the code and understand the outputs, visualize the output by yourself. So, basically this is a self paced course I have designed only for you. So, I have provided small video lectures for critical concepts where I felt it is necessary. At the end, I have given a jackpot problem of worth 5,000 rupees. If you solve it, you will be eligible for the contest. I believe that jackpot problem will be solved by yourself. So, all the best, let us get started. Yeah, so in your screen, so here I would like to introduce to you MATLAB and SIMULINK. So, first of all, why should we learn MATLAB and SIMULINK? So, basically MATLAB and SIMULINK, it is industry standard tool for mathematical modeling, system simulations and algorithm development. So, mathematical modeling, if you have some complex systems to visualize the behavior of the system. So, first of all you have to do the mathematical modeling for the understanding of the behavior of the system. So, basically this is extensively used in academia, industry for solving real world engineering problems. What are the real world engineering problems? Suppose if I tell you, you have to tell the temperature of the surface of the earth, how will you do that? If I tell you what is the distance between a particular planet to a particular planet, how will you do that? If you want to solve some control problems, you are not aware about that. Suppose if you want to design a rocket system which can land on Mars, how will you do that? So, here mathematical modeling will be helpful for you and to design the control algorithms according to that. Enables rapid prototyping, data visualization and complex computations irrespective of the domain. Basically, it facilitates interdisciplinary collaboration across various domains. Here in MATLAB and SIMULINK, you will have you can have toolbox from the biomedical engineering, you will have toolbox from the embedded systems, you will have image processing toolbox, you will have aerospace toolbox. So, all interdisciplinary domains, interdisciplinary engineering, basic interdisciplinary engineering domain you will have in a single platform. What is modeling and simulation? So, basically what is modeling? Just now I told you, creating mathematical representation of a physical system. Suppose you want to design a missile. So, without firing that missile, how will you know that in real time how it will behave? So, here the modeling is required. So, basically in modeling, that is the physical representation. Basically you will have some law of physics, that law of physics you have to convert into mathematics and you will run that mathematics in your PC and you will try to visualize the behavior of your system. Simulation, that is nothing but that is running this model to predict behavior under various conditions without, suppose in the case of missile systems, suppose you do not have to fire each and every time, you do not have to fire that and you can predict the behavior. before firing, before actual firing of that missile, useful in testing system performance without physical implementation. If you want to test how it will behave in a certain condition, suppose it will have some noisy environment, noisy measurements, some disturbed environment, how it will behave and how your basically control or autopilot will behave, and basically how your system will perform in that condition, it will provide you that insight. It will provide, reduce development cost and accelerates innovation. Yeah, obviously it will reduce the development cost, because you don't have to uh, physically model that system, and physically you have to fire, or you have to physically fly that aircraft, or whatever it is your system. You don't have to do that physical realization. So before that, you can use this simulation and modeling by simulation and modeling to predict the behavior, to predict the performance, to know the performance, and you can tweak that performance, you can improvise the performance without actually using that physical system. So helps engineer optimize design before actual production. So each and every angle engineers try to validate the system. Advantages of modeling and simulations: it eliminates the need of costly physical prototype. You don't have to do a physical prototype each and every time. So in simulation and modeling and simulation, it will give you that idea, it will give you that information. Allow safe testing of dangerous and expensive scenario. Enhance understanding of system behavior before deployment. Enable iterative design improvement through simulation results. Suppose if you want to change something, some parameter, and you want to say, hey, what would be the anticipated behavior if I change this. So in a snap you can do that if you have that modeling and simulation capability. So that MATLAB and SIMULINK will you provide that. Provide a risk-free environment for exploring various design alternatives. Suppose one particular design it is working, and I want to how it will behave if I will have another design or alternative design, its behavior, how it will perform in real time. So this kind of thing, or basically you can explore various designs in this way if you will have that modeling and simulation capability. Used for designing, tuning, analyzing control systems. Control systems basically autopilot designs. You can tune like PID controller. Simulink provide graphical. Yes, what is Simulink? Simulink provides that is a graphical block diagram modeling for real world applications. Like suppose if you take an example of an aircraft, its propeller, you can model in a block diagram basically. So basically Simulink provide you that graphical representation of a particular subsystem and the complete system. It facilitates PID tuning, state space representation, adaptive control, and there are so many control algorithms there in Simulink. You can directly use that. You can have that Kalman filter, you can have different kind of filter, you can directly use that in your model, in your control system design, in your algorithm development process. Allow real time testing and verification of control algorithms, basically software in loop simulation, hardware in loop simulation you can do by using MATLAB and SIMULINK. So used in industries such as aerospace, automotive, and robotics for automation. There are so many companies they use MATLAB and SIMULINK, like SpaceX, NASA, like BDL, like there are ISRO, DRDO, all of them they use MATLAB and SIMULINK for their design purpose. Yes, what are the Simulink in MATLAB and Simulink in engineering? So which which domain it is useful to use that MATLAB and Simulink? So basically in mechanical engineering, so like structural analysis you can do, heat transfer, dynamics, fluid simulations you can do. Electrical engineering like signal processing, control system design, circuit simulation, embedded systems. Aerospace engineering, flight dynamics, navigation systems, guidance and control systems. Civil engineering, structural stability analysis, earthquake engineering, hydrodynamics. Biomedical engineering, medical image processing, biosignal analysis, psychological modeling you can do here in MATLAB and SIMULINK. Real world applications, so autonomous vehicle sensor fusion, path planning and obstacle avoidance kind of thing you can do. Renewable energy, wind turbine modeling, solar panel performance simulation, in robotics, motion control, AI based navigation and reinforcement learning. You can also have that what it is called here. Okay. So, embedded systems, hardware in loop simulation, testing, microcontroller interfacing. So, financial modeling, that is the risk assessment, portfolio optimization and data analysis, data analytics. Suppose if you want to observe one share and you want to predict something, how it will behave after a certain time. So, you can have that risk assessment of a particular share. So, this kind of work, basically this kind of real world applications you can use MATLAB and SIMULINK. So, here that is the model based design approach. Already I have told you a systematic approach using graphical models to develop embedded systems. So, basically in model based design, so SIMULINK provide you that auto generated code which is complied with standard standard of code, like coding standards basically. So, replaces traditional hand coded development with automated code generation. It provide you that leverage we will have in model based design approach if we use that SIMULINK. Integrates modeling, simulation, code generation and testing in one workflow. You do not have to migrate your platform. So, in a single platform you can have that modeling, you will generate that deployable code and you will test that code in hardware, real hardware, and you can do that real time testing. Allow early verification and validation of the system design. So, if you do that software in loop simulation, model in loop simulation, hardware in loop simulation, it gives you the complete system design confidence. If anything needs to be changed or needs to be improvised in the early stage, in this stage you can do that. Enhance efficiency by detecting design errors before hardware implementation. Impact on complex system design, enables rapid prototyping and real time testing for control algorithms, reduce development cycle and improve product reliability, ensures better integration between the software and hardware components. Widely used in safety critical applications such as aerospace, automotive and medical devices. It supports parallel development of hardware and software for faster deployment. You might have also heard that is how model based design it is used in also missile systems and space systems. So, last so lastly, that is MATLAB and SIMULINK are powerful tool for engineers in various disciplines. So, modeling and simulation improve design efficiency and reduce cost. Control system applications span multiple industries, enhancing automation. That is, model based design simplifies the development of complex embedded systems. You can you can design the complete software, GNC software, by using model based design. You can have that auto generated code and you can directly deploy that code into hardware. Future innovations rely on these tools for automation, AI and real time applications. You can also have that generative AI here in MATLAB and SIMULINK. It provides you the very efficient toolboxes related to artificial intelligence. So, thank you. If you have any questions, please reach out to me, that is aerosastra@gmail.com, and be with us at aerosastra.in. Thank you.